Hey everyone, we begin the trigonometry unit today, in particular functions and graphs. Some of this is a little bit of review from 20-1, but the majority of it will be new. We're going to look at angles in standard position, which you touched on in 20-1 in degrees, but now we're going to also talk about an angle measurement called radians. We're going to develop and apply the equation of the unit circle, and we're going to solve problems using trig ratios, and then finally look at the graphs of sine and cosine, tangent, and the transformations of sine and cosine. Okay, so let's look at rotation angles in standard position. Just to review here, angles can be measured in degrees where 360 degrees is equivalent to one complete rotation. Rotation angle is formed by rotating this initial arm, okay, through an angle theta about a fixed point, okay. Now most often we put this on a coordinate grid, okay, and the vertex is the origin of the coordinate grid, and the positive x-axis is where the initial arm is. Okay, so and that's, if you draw it like that, that's considered drawing the angle in standard position. Okay, if we have a positive angle, we are rotating counterclockwise, and a negative angle, we're rotating clockwise. So each of those show an angle of 235 degrees and negative 247 degrees. And we should write that in there if we're showing that in standard position. Good, let's put this to work on example 1. So sketch the rotation angle in standard position and state the quadrant in which each angle terminates. So all angles begin from the positive x-axis if drawn in standard position. If we rotate to here, we've gone 90 degrees. Here, 180, 270, and we want 290. So we're going to go, well, 20 degrees past 270. Okay, and we got to put a little arrow on the end of that rotation angle to indicate which direction we went in. And that there would be an angle of 290 degrees drawn in standard position. Negative 135 degrees, negative this time, so we're rotating from the positive x-axis still, but we're rotating clockwise. Okay, so to here would be 90 degrees, 180, so that's too far. So we want to land somewhere in between here, and that would be approximately an angle of 135 degrees. And then finally, 750 degrees. Well, 750 is definitely around more than once. Positive angles, we're rotating this way. So once around would be 360 degrees. Twice around, add 360 to that, would be 720 degrees. And we're really just then another 30 degrees past that. So let's go around twice. There we go. And then 30 degrees past that would land us in quadrant 1, right here, and that would be our rotation angle of 750 degrees. Good, let's look at the next page. Another scenario we could be given is like in example number 2, where they say a point lies on that terminal arm of a certain rotation angle, and they want you to draw it in standard position based on given that point. So first you'd plot this point just like you would normally, -3, so left here, and then up 4. So we should be right here at -3, 4, and then you draw the angle going through that point, and there's your terminal arm. To draw that in standard position, we should probably throw an angle on there and label that as theta. And we'll do more follow-up or more extensive analysis of that later on. All right, let's draw this one, -7, -2, so left 7 down -2. Okay, draw a terminal arm through there, label that point, and then draw your rotation angle coming from the positive x-axis again, label that theta, and there we go, our angle in standard position. Coterminal angles are basically angles that share the same terminal arm. So if we say draw an angle of 150 degrees, that would probably be somewhere in here. Positive angle, 150 degrees. Okay, then asked to draw another angle to -210 degrees. Well, here's 180. 210 would be 30 past that, and there's our angle of -210 degrees. Looks like it's landing in the same place, isn't it? And then finally, a rotation of 510 degrees. So once around gives us 360, and if you go 510 minus 360, you would get 150. So we go another 150, And that, once again, lands us in quadrant 2 there, seemingly at the same place, and I think it is. This one was 30 degrees away from the negative x-axis, that one was 30 degrees, and same here. So all three of these rotation angles are basically coterminal angles. They share the same terminal arm. Okay? The principal angle, though, in particular, is basically the angle that has the smallest positive rotation angle to that terminal arm. So given above here, the principal angle would be 150 degrees. The principal angle is always between 0 and 360 because it's the smallest positive angle to get to that terminal arm. Now, as you notice, there's many different rotation angles we could have. We could just keep adding 360 to get to another rotation angle, or subtract 360, say from 210 or from 150, and all of these would be coterminal angles. So there's a generic way to kind of write that so that we cover all of the coterminal angles, and that's to write your principal angle plus 360 degrees, that's one full rotation around, times n, which is basically how we get multiples of 360 degrees, as long as n is an integer, okay, positive or negative whole number. That way we're adding full 360 degree rotations. So given above, we would write all coterminal angles as 150 degrees plus, because that was our principal angle, plus 360 degrees n, where n is an element of the integers. That's how we're going to write that. Okay, example 3. We are going to basically come up with, first of all, the angle or angles in the domain from negative 360 to 360, which are coterminal with each of these angles. Then, part I, we're going to look at the expression like we did up above here, that would basically show all coterminal angles with that given principal angle, or with the principal angle. So let's take a look at this. So first of all, we need to find a coterminal angle in this domain. Well, if we take that 285 and we add or subtract 360. Now if we add 360, we're going to be bigger than 360 here. But if we take away 360, we will have the coterminal angle of 75 degrees, negative. Okay, so negative 75 degrees is coterminal with 285 degrees, and it's between negative 360 and 360. So there you go, there's our coterminal angle. And I is to write the statement that says all of the coterminal angles. So we start with our principal angle. Now the principal angle has to be between 0 and 360. So the negative 75 wouldn't do that, but the 285 would. Okay, plus add a full rotation times n, multiple rotations, where n is an element of the integers. And that would be our answer. Negative 13 degrees. Why don't you guys try this one and see as well. Just keep adding and subtracting 360 until you have a number between 0 and 360 to get a, well, to get a principal angle, but also to get a coterminal angle. Okay, pause your video, please. Okay, check your answers. For B, a coterminal angle with negative 13 would be 347 degrees. The expression that states all coterminal angles, take the principal angle, 347 degrees, number between 0 and 360, plus full rotations, 360 times n, which means multiples of 360, and then n is an element of the integers. Okay, 395, coterminal angle 35, and then we have 35 plus 360 times n, where n is an element of the integers. Okay, let's look at the next page. Okay, reference angles are basically acute angles formed between the terminal arm and the rotation angle and the x-axis. So if you see this terminal arm drawn here of an angle in standard position, the reference angle would be this angle here, the angle between that terminal arm and the x-axis, and it has to be acute, meaning less than 90 degrees or equal to. Okay, so if this diagram shows an angle, rotation angle of 120 degrees, our reference angle would be 180 minus 120, which would be 60 degrees. And there we go. Let's try example 4. So in each case, we're going to sketch the rotation angle and state the reference angle. Okay, so 240 degrees, let's see if we can draw that. That should land us somewhere down here. 240 degrees, 43 degrees, sorry. And the reference angle would be this angle between that terminal arm and the x-axis. Now the best way to get this is not to memorize this instructions they have below here, but just to look at it logically. If all the way to here is 240 degrees, 43 degrees, and from here to here we know is 180 degrees, then if we take 243 and subtract 180, we should have this reference angle here, which is going to be 63 degrees. There we go. Reference angle equals 63 degrees. All right, why don't you guys try B and C? Let's see if we get the same reference angles. Pause your video, please. Okay, so 337 degrees, we should have gotten a reference angle of 23 degrees, and really that would just be found by going all the way around to 360 and then taking away the 337 part. That would give us this acute angle here between terminal arm and the x-axis. 70 degrees, a little bit tricky because the actual rotation angle is the same as the reference angle. Okay, so 70 degrees, then the acute angle between that terminal arm and the x-axis, same angle, 70 degrees. So they kind of sum things up here. I do not recommend that you memorize this. I would recommend that you draw it and you understand what you're doing, and then we'll be good to go. Okay, let's take a look at the next page. So example number 5, state the reference angle for each of the following rotation angles in standard position. Again, first thing I would suggest you do is sketch it. 195 degrees, that's just past 180. That would be 195. So to find the reference angle, which would be this angle here, we would simply go 195 minus 180, and we're left with this little tiny reference angle here of 15 degrees. Good. Okay, why don't you guys try B and C, and then we'll check back and see if we have the same reference angle. Okay, pause your video, please. All right, welcome back. So let's see how we did. Negative 258 degrees. Did you guys draw that in the clockwise direction, hopefully? And then our reference angle ends up being this angle right here between that terminal arm and the x-axis, which can be found by going just 258 degrees, take away the 180 part, this part here, and we would get 78 degrees as our reference angle. Negative 810, that would be once around 360, twice around 720, and then another 90, and all in the negative direction, would land us right here on the negative y-axis, giving us a reference angle of 90 degrees. Reference angles are always positive and always less than or equal to 90 degrees. Okay, let's look at our last example. Determine 4 angles between 0 and 360, which have the same reference angle as the rotation angle of negative 128 degrees. Let's start with there. Negative 128 degrees, negative, we go this way. 128, land us somewhere over here. Okay, so if this is negative 128 degrees, let's find our reference angle, which would be this angle here. Okay, probably by going 180 minus 128. Not probably, I know it is. And we should get a reference angle of 52 degrees. Okay, so 4 angles between 0 and 360. So 52, well, first of all, that one that we have, that we just drew, we could go this way to get to it, really by going 180 plus 52, and that would give us an angle of 232 degrees. There's one. We could also have an angle in quadrant 1 with the same reference angle of 52, and that would simply be 52 degrees. Quadrant 2, reference angle 52, found by going 180 minus 52, and we should have 127 degrees. And then finally, quadrant 4, reference angle 52, how do we get our rotation angle? We go all the way 360 minus 52, and we should have an angle of 308 degrees. And there we go. There would be our 4 angles. And that concludes lesson 1. Good luck with the assignment, and we'll continue on with lesson 2. Thank you for listening.